Good morning, grade 7s. Welcome to WorksheetCloud, grade 7 Natural Sciences. My name is Mrs. Hall, and I look forward to teaching you this lesson today. If you have a question during the lesson, please send an email to grade7@worksheetcloud.com, and we'll do our best to answer you. Let's get started with today's lesson. So today's lesson is on kinetic and potential energy. That is what I'm going to be focusing on today. And then in the following lessons, we will look at energy transfers and energy in a system. But today, I just want to focus on kinetic and potential so you get a solid understanding. So it's all about bite-sized chunks of information in order to be able to understand fully, grade 7s. So today's learning objective is to understand that there are different types of energy, but today we're focusing on potential and kinetic. So what is energy? Energy is the ability to do work or cause change. Energy comes in two basic types, kinetic energy and potential energy. Kinetic energy is the energy an object has because of its motion. It depends on the object's mass as well as the object's velocity. Potential energy is the energy that results from the position or shape of an object. So let's take a look at these pictures over here, and you can tell me what the connections are that you see. Right, you have apples or fruits hanging from a tree there. You have wood burning over here. You have batteries, and you have a dog running along a riverbank with a stick in its mouth, showing great joy. What is the connection here? Okay, these are all different kinds of energy stores. Okay, everything stores energy in different ways. So from those pictures, we had chemical energy from the batteries, okay? We had kinetic energy from the dog running. We had gravitational potential energy from the fruit hanging on the tree. And then we had thermal as well as chemical energy from the heat of the fire and the burning of the firewood. So let's take a look at these different energy stores and the transfers that happen from eating food. Okay, so you transfer the energy into different stores. Okay, so you start by eating your delicious meal. Okay, and you will find that your energy is transferred. Okay, from chemical potential energy from the food you're eating into your body. As it gets digested, you are then able to move. Okay, you have kinetic energy. You have energy of motion. You also have thermal energy because you've got to maintain your body temperature at 37 degrees Celsius, and that takes energy from your body. And then the chemical stores is when you make different compounds in your body. Okay, and let's take a look at that in a little bit more detail. So I've taken an example of an energy drink, okay? So chemical potential energy is the energy stored in the particles of substances such as food and even fuel. In order to release this energy, a chemical reaction takes place, and I used an energy drink. Okay, so there we have somebody drinking their energy drink, just like you like to do before an important sports match, whether it's netball, rugby, soccer. Oh, don't you miss playing sport, grade 7s? I miss watching you. Okay, so the athlete drinks the energy drink. His body digests it. This would be a chemical reaction taking place in your body. And he gets more energy to run the race as the energy is released from drinking that energy drink. You can also find the amount of chemical potential energy by reading the label on the energy drink bottle. And there you would have it over here. It tells you exactly how many kilojoules is in that energy drink. Okay, your energy value. You see it over there. Because, yes, grade 7s, energy is measured in joules. Okay, so let's do a quick assessment from different energy stores. So we've got our pictures here, and let's match the images below to their energy store. So I have a candle burning, I have a cheetah running, I have a ball with elastic bands, I have someone jumping out of an aeroplane, parachuting, and I have a delicious burger over here. Okay, so the chemical energy, the chemical store is in the burger. Okay, by eating that, I have chemical potential energy to allow me to do different things. The energy of motion is in the cheetah. That would be kinetic energy. The gravitational potential energy is in the parachute, okay, because of the pull of Earth's gravity. If you were not using a parachute, I think you would fall pretty hard to the Earth's surface, okay, due to the pull of gravity. And then we have over here the elastic potential, which is in the rubber bands, which is from the elastic stretched around this ball. So, as I said earlier, kinetic and potential energy, both types of energy are measured in a unit called a joule. Okay. So what is kinetic energy? Kinetic energy is the energy of motion. Examples of kinetic energy include objects that are moving very slowly, like the snail over here. Quite relaxing to watch, but it still has energy of motion. Okay, or let's move me out the way. It could be moving very fast. Okay, watch this. Right, quite a difference. But both have kinetic energy, energy of motion. And before I move to my next slide, grade 7, just remember that speed kills, okay? So when you're getting ready to get your driving licenses. Okay, so if it's moving, then it's got kinetic energy, okay? Even the electrons are flowing electricity, and the photons of shining light have kinetic energy. So, to figure out how much kinetic energy an object has, you must know the object's mass and its velocity. Okay, so velocity would be the speed at which it's traveling. So we could work out the kinetic energy of the snail and the kinetic energy of that car as it was moving. Okay, so you would use a formula like this: kinetic energy equals mass times velocity squared divided by 2. Okay, so mass multiplied by velocity squared divided by 2. Now, I don't want to encroach on your grade 8 curriculum and you work out these formulas in grade 8, but it's a lot of fun working out the kinetic energy of an object. Okay, say for example, you could work out the speed of that car, or the kinetic energy of an asteroid hitting Earth. So interesting times ahead for you, grade 7s. To give you something you can relate that to, 1 joule is equivalent to lifting up an apple from a table to take a bite. 100 joules would be the heat your body produces in 1 second. 1,000 joules would be lifting 100 kilograms just up 1 meter, so doing those bench presses or lifting up those weights. And 100 million joules is energy from a gallon of gasoline, so a lot of fuel there, a lot of energy. So total energy that you use is measured in joules, and you can abbreviate it with a J. Right, let's take a look at potential energy. And before we carry on, just take a look at the position of this rock over here. And now you will understand it so much better. So what is potential energy? Potential energy is the energy of a body or a system with respect to the position of the body or the arrangement of the particles of the system. Okay, so here we have gravitational potential energy. Okay, look at the glass, look at its position on the table. Here we have chemical potential energy based on the chemical reaction that will take place in this battery over here. And here we have elastic potential energy based on the slingshot over here that they're trying to catapult something out into wherever they might be wanting to do it to. Yep, boys get up to mischief. I don't know what they're up to there, but they're up to something. Right. So, for gravitational potential energy, you need to remember the following. The higher up and more mass the object has, okay, like that glass on the table, the more energy it will have once it starts moving and the harder it will hit the ground, okay? For elastic potential energy, the further you stretch the slingshot, like you saw in that picture, the more energy it will have when you let it go. Okay. For chemical potential energy, depending on the size of the battery, the substances used, was moving me there, depending on the size of the battery or the substances used, depends on the amount of energy that will be put out and how much will come out at a time from the battery. So, the best way to demonstrate and explain both kinetic and potential energy working back and forth together in conjunction is another word, is with a pendulum, which is simply a weight hung from a string and a pivot. So let's take a look. Watch it. It is a pendulum moving from left to right. And it just keeps swinging. Okay. So, how does a pendulum work? A pendulum works by converting energy back and forth. It's a bit like when you're on a roller coaster ride, okay? When you're at the top and when you're at the bottom. Okay, the highs and the lows, okay? When the bob is highest, that's that ball, in other words, when it's furthest from the ground, it has maximum stored energy. It has the potential energy. As it accelerates down towards its lowest point, which would be its midpoint near the ground, this potential energy is converted into kinetic energy, which is energy of movement. And then, as the bob climbs up again, it goes back to potential energy. So as the bob swings or oscillates back and forth, it repeatedly switches its energy back and forth between potential energy and kinetic energy. Here are some other examples for you to take a look at. Okay?
The marble is placed on the right side of the track. It's let go. And the marble is slowly losing velocity. And that's because the track's applying an outside unbalanced force in the opposite direction of the marble's motion. This is called rolling friction. And this is why the marble can never go as high as the original point.
Okay, and the next one. So if you just looked at that, the potential energy peaks on each side of the track. okay, where the ball stops moving up. And then the kinetic energy is at its greatest at the lowest point in the track when it starts to move faster.
There's a wooden ring.
Let's move me out the way again, sorry.
On top of a flask and a piece of chalk on top of the ring. The ring is quickly removed and the chalk goes straight down into the flask. Both the ring and the piece of chalk are at rest and they have inertia. An unbalanced force is applied to the ring and the ring moves as a result. That force is not applied to the chalk stays there. But the ring is no longer applying an upward force on the chalk, and therefore gravity is the unbalanced force that makes the chalk move down into the flask.
Okay, gravitational potential energy. Let's move me out the way again. Okay, so the potential energy is the greatest where the object is at rest at the top of the ring, and the kinetic energy begins the moment that the ring is removed. Kinetic energy peaks the moment before hitting the flask's bottom. Okay, this one's an interesting one. Let's take a look. How about a human slingshot? I want you to look at the different types of energy here, grade 7s, and think about it while you're watching.
Oh my, is it recording? Wait, I'm not, okay.
Okay, so those are for the wild children out there. I'm pretty sure you love that. And for those of you who've done it, wow, I'm impressed. Again, freaks me out. Can't do it. Can't jump out of a parachute. I can't get into one of those human slingshots either. Way too scary for me. I think I'm scared of heights and speed. Okay, so what were the different types of energy that you saw there? The first one, grade 7s, was elastic potential energy. So energy was stored in the elastic material as a result of stretching the elastic out. Very ingenious way of doing it when they got onto that little motorbike and pulled the elastic back. Okay, the amount of energy stored in a system like this depends on the stretch of the material. So the further back they went, the more energy they released. Okay, the more stretched the elastic is, the more elastic potential there is. There was also gravitational potential energy in that video. An object has gravitational potential energy based on its position above the ground. Okay, the person in the slingshot had the gravitational potential energy. The gravitational potential energy is energy that is stored in an object because of its position above the ground. So literally it was flung up into the air, and then where was it supposed to go? The earth attracts all objects towards its center with the force of gravity. So, grade 7s, I hope you found that interesting. I hope you learned something new today. Please do not go out and make yourself human slingshots, okay? I don't want to hear any reports of children being injured because of Mrs. Hall's science lesson on potential and kinetic energy. I hope I haven't given you any ideas. Grade 7s, have a beautiful day. Enjoy the rest of it, and I will see you next week because, yes, I think Friday is a public holiday. Enjoy. Bye.